Hello students, my name is Santosh Kumar and I am the course instructor for Machining Sciences and Tool Design. We are discussing module number 3, that is cutting tool materials and machining induced surface integrity. So in this video we will be discussing about fracture roughness. So as you can see, as the cutting tool proceeds, this is the cutting plane, that is shear plane, which we have discussed in the other videos. As it proceeds, if the cutting when the cutting steel at very low speeds, a special type of roughness is frequently observed due to the subsurface fracture that you can see in the picture. So in the subsurface you can have this kind of a surface roughness. So when the chip fractures, the crack is frequently followed to follow the approximate path of maximum shear stress. So and you can observe the line AB. This is where the subsurface cracks is formed, and you can compare this with this figure. So the E dash, the circle E dash, so which represents the circle E dash represents the constant shear stress magnitude, while the curved lines which are curved like line OG, so which you can compare with the line AB in this figure. So this is a curved line AB. So this you can compare with the line OG, so which is at 45 degree to this line. So this is a figure which you can compare for the previous one. This is how the elastic stress pattern will be for a concentrated load applied onto the plane surfaces. So next, if we observe when the crack runs completely across the chip, the surface has a moirey appearances, as you can see in the figure C. So that is, it consists of a dull and shiny appearances. The shiny appearances which you can see are because it is actually cut, while the dull or gray areas which are uncut regions of the finished surface. So as that speed is increased, the cracks may not go all way across the chip. Such chips appear to be continuous. But careful examination of such chips also, the finished surface reveals that many gray craters, like as shown in figure D, so this is how it appears. So these craters are due to same subsurface fracture. So above certain speed, a subsurface pattern will no longer be found, and this source of surface roughness disappears. So that is after certain cutting speed. So and this one will tell you, for example, for low speed fracture pattern, so which we are discussing in the previous slide. We discussed about high speed fracture pattern. So this is example for low speed surface fracture, and a resurfaced steel will give a fracture pattern of shorter pitch and likewise of a smaller depth. Thus, resurfaced look like a figure C, whereas non-resulfurized steel look like a figure B. So the surface finish obtained by resulfurized steel is far better than obtained from non-resulfurized. So when cutting in the low speed region, where rough subsurface cracks are apt to form.